Speed is the superpower of computing. Flow's Parallel Processing Unit, or PPU, is a licensable IP block that integrates directly into a CPU chip, enabling the next generation of CPU performance. The PPU-powered CPU is backwards compatible with existing software and comes with a step-by-step migration plan so you don't have to start software development from scratch. The PPU works alongside the CPU as a coprocessor, handling parallel parts of the workload. This allows the CPU and PPU to divide the work efficiently, each doing what it does best. The PPU is instruction set independent, so it can be used with ARM, x86, RISC-V, and Power architectures. Multicore CPUs are plagued with issues such as poor scalability, inadequate memory coherency between cores, and expensive synchronization. The PPU was designed specifically for efficient, general-purpose parallel computing. It supports high throughput, shared memory access across processing elements, and efficient communication between them, addressing synchronization and cache bottlenecks. The PPU also offers perfect linear scalability. The result is significantly better performance with at least 2 times gains out of the box, and even up to 100 times when optimized. Flow's PPU architecture features a number of processing elements, or PEs, built specifically for scalable and efficient parallel execution. By allocating part of the chip area used for CPU cores to the PPU, overall performance can be improved without increasing the chip footprint. This diagram shows how Flow's PPU fits into a modern, high-performance CPU chip. We'll walk through it part by part. At the chip level, we see a multi-core CPU at the top, each core with private L1 and L2 caches. Below is the PPU, which includes a number of processing elements. The PPU's processing elements are connected to L1 and L2 caches, and to active memory units, which support efficient parallel execution within the PPU. The CPU and PPU communicate using a work-spreading network to assign parallel tasks and a return channel to send results back. In the center, we can see how the processing elements are connected through a high-bandwidth mesh network. This interconnect enables low-latency communication across cores and shared caches. The PPU supports a wave-based synchronization scheme, which lets processing elements stay in sync with minimal overhead, helping execution scale smoothly across all cores. On the right, we zoom in on a single processing element. Each processing element is super pipelined and uses static superscalar BLIW architecture for high throughput execution. The pipeline includes fiber creation logic, which dynamically creates tasks, operand select, which pulls data from registers, a chain of functional units, including floating point units, and integer ALUs surrounding a memory chain with latency compensation, and finally, write back with optional communication to the CPU via the return channel. This design allows each processing element to execute parallel instructions efficiently with low latency and high determinism. This performance comparison indicates the performance boost potential of Flow's PPU technology. Using our proof of concept, we benchmarked the speedup of a high-end 256-core PPU-powered system against state-of-the-art consumer and server CPUs in compute, memory access, and synchronization patterns. In these compute pattern tests, the 256-core PPU was on average 24 times faster than the 72-core Google Axion and 43 times faster than the 96-core AMD EPYC Zen 5. The development of the PPU commercial version for RISC-V is proceeding rapidly. These tests show that Flow's entry-level RISC-V-based 16-core PPU, paired with a 1-core RISC-V CPU, achieves substantial speedups compared to a 4-core RISC-V CPU. In the interleaved access pattern test, the baseline 4-core RISC-V CPU was 4.7 times faster than sequential execution, and a single-core CPU with a 16-core PPU was 38.1 times faster than sequential, showing the PPU's potential for improved parallel performance. We are busy implementing several new performance-enhancing technologies into the PPU commercial version, as well as creating a PPU configuration benchmarked against a 64-core RISC-V server CPU. Speed is the superpower of computing. The PPU enables the next generation of CPU performance.